So hello guys, in this video we are going to solve this problem. So in this problem it is given that if this expression, which is 3x square plus 1 divided by root of x power 4 plus x square, is greater than equal to f of x, where f of x is a constant function in x lie between 0 to root 2, then we have to tell the minimum value of this integral can be. So this expression is same as this expression, and we have to tell the minimum value of this integral. So let's see how we can do this. So first of all, you see this expression, which is 3x square plus 1 divided by root of x power 4 plus x square. So this expression you can write in this way. You can take the x square outside of this root and it will become like x, and inside is x square plus 1. Now you can split this 3x square plus 1 in this way, x square plus 1 plus 2x square. Now you can also write in this way, like x square plus 1 divided by x multiplied by root of x square plus 1, and 2x square divided by x multiplied by root of x square plus 1. Now we have these two things. Now after simplifying, like you can cancel this with this, and here it will become like root of x square plus 1, and here it will become like 2x. So we have this root of x square plus 1 divided by x, and this 2x divided by root of x square plus 1. Now we know the x lie between 0 and root 2, and for x between 0 and root 2, these two are positive numbers, and between two positive numbers we can say am is always greater than equal to gm. So am of these two, which is this plus this divided by 2, is always greater than equal to the root of these two terms product. So here this will cancel, and this x will also cancel, and here the remaining thing is only root 2. So you can take this 2 to the right hand side, and this will become like the summation of these two terms is always greater than equal to 2 root 2. This we get after applying am greater than equal to gm. Now in the problem it is given that this expression is always greater than equal to f of x, where f of x is a constant function. So we find out, like, this expression is always greater than equal to 2 root 2. We find out this by applying am greater than equal to gm. Now our x is lying between 0 to root 2. So we have to check, like, this minimum value occur for which value of x. The x value for which the minimum value occur is lying between 0 to root 2 or somewhere else. So we have to check that. So if you see, for getting the minimum value, uh, the numbers like these two numbers, one is this number and one is this number, both must be the same for am is equal to gm. So these two number must be the same for the minimum value. So if you equate these two, so it will become like, if you cross multiply, so x square plus 1 in the left hand side and 2x square in the right hand side. So from here you will get x square is equal to 1 and x is equal to plus minus 1. But we take only x is equal to 1 because we know our x is lying between 0 to root 2. And from this we can also see that the minimum value is occurring at x is equal to 1, which is lying inside our range of x. So we can say that this integral must be greater than equal to, if you put the minimum value of this expression, so which is 2 root 2, and here dx, and if you do the integral, so it will become like, final answer is this 4, 2 root 2 multiplied by root 2. So this integral will come 2 root 2 times x, and if you put the limit it will come like 4. So we can say that this integral must be greater than equal to 4, because this expression minimum value is 2 root 2 for x is equal to 1, and if you put that in the integral, so you will get this integral is always greater than equal to 4. So this inequality we get for this integral. So we get this integral must always greater than equal to 4. So for uh, in this case you can say that this minimum value is 4. So in this way we can solve this.